Yo, hope everyone's well. Okay, so guys, this is gonna be an example where we have a radical function equaling a linear function. And in this example, it's gonna turn out that you're gonna end up getting some kind of quadratic involved, and you have to solve that quadratic. Okay. So here it says solve, and I provided you some steps based off of the steps that we talked about in our previous classes, right? Here, you don't have to follow these steps, but to give it more like consistency, right? And to make it more systematic, like this is one way you can go. Okay, so step one, isolate the radical. Step two, so let's do that right now. So here, to get this alone, we're gonna have to get rid of this -1, right? So you're gonna add 1 to both sides. And you're going to get square root of x plus 1 is equal to x minus 2. And in step 2, you're going to square both sides. Squaring that is going to undo this. If you want to know why, look into the radical properties. Okay. And but here you're just going to get this x plus 1. And here, when you're squaring this is going to be a review, a FOIL. Okay, this is a perfect square. This is a shorthand for this. Okay, so now you just use FOIL. Okay, it's the distributed property. Cool. So here, when you distribute the first, outer, inner, last terms, you're going to get x squared minus 2x minus 2x plus 4. And then we can simplify the right side. So it's x squared minus 4x plus 4 is equal to x plus 1. Okay, and then step 3 here, make one side 0 by moving all terms to one side. So we're going to move this to the other side. Once again, inverse operation, subtract x, subtract -1, subtract x, subtract -1. This goes away. So now you have 0 is equal to x squared minus 5x plus 3 is equal to 0. And then when you look carefully at this, you should see that this is a quadratic being equal to 0. In other words, we have to solve the quadratic, find its roots, and we can use multiple methods, but here I'm going to use the quadratic formula because this question I created in the office hours, and yeah, this one's not that nice, not factorable. Okay, so here we're going to use the QF. So negative b plus or minus square root of b squared minus 4ac over 2a negative b, so it's going to be 5 plus or minus negative 5 parentheses squared, so then that's going to be 25 minus 4 times a, which is 1, times c, which is 3, all over 2 times 1, which is 2. Great. This is x, okay? And then you just simplify the radicand, okay? So here, the square root of this thing is just 25 minus this, so 4 times 1 times 3, so this is going to be 25 minus 12. So then that means that that's just 13. X is equal to 5 plus or minus square root of 13 over 2. Okay? But we still have to check these, and these numbers are not nice, okay? So, but the way that you would do that is these two solutions, 5 plus square root of 13 over 2 and 5 minus square root of 13 over 2, you want to plug this back in the original and see, is the left side truly equal to the right side? Okay, you guys try it out. Okay, I'm gonna cheat a bit. Okay, I'm gonna use Desmos, and you're gonna see actually graphically. So here we're doing an algebraic and a graphical solution. Okay, when you put this in TI-84 or Desmos, you're gonna see that there's only one solution, only one of these values works. Okay, so here for convenience sake, I pulled this up, right? In your TI-84, this one's like y1, this one is like y2. All those are it's just the left side of the equal sign and the right side of the equal sign, the expressions, right? The original equation. okay? And we're trying to see if they intersect. In this particular example, they do intersect, right? The radical of a linear, right? And there's only one intersection, meaning that one of the roots is extraneous. And you guys, as an exercise, should find out which one and then report back to me, okay? But visually, you can see that it's this thing right here. Okay, so they have the same x value, 4.303, and the same y value. So when x is 4.3, whatever that is, okay, this is an approximation. You're going to get the y is 1.303, okay? But here, since we're just solving for x, we just need that 4.303. So you just got to find which one is associated with that 4.03 solution, and that's going to be it. Cool. All right. Hopefully this made sense, and if not, ask questions, and yeah, I'll see you guys later. All right. Peace out.